Hello, everyone, and welcome to our webinar today. Today, the title of our webinar is From Edge to Enterprise, Building Scalable MES Architectures with MQTT. My name is Arlen Nipper. I'm the president and CTO and co-founder of Cirrus Solutions. Been doing automation systems for about the last 46 years, and about 26 years ago, I had the great opportunity to work with Andy Stanford Clark from IBM, and I was one of the co-inventors of the MQTT protocol. I'm quite pleased to be joined today by Sam Russum. Sam is the VP of Business Development at Kanoa. And Sam, can you tell us a little bit about your background?
Yeah, hey there, Arlen. Thanks a lot for having me here with you all today. So as Arlen said, I'm in charge of sales, marketing, and building demos and things like that for the Kanoa MES platform. I started in systems integration 16 years ago, doing some PLC programming and things like that on the shop floor. Eventually got into more smart manufacturing, data-driven projects, eventually running the smart manufacturing department and strategy for that integrator. And we got to see a lot of different pieces of software out there as we were doing those types of integrations. And when I saw Kanoa, it just floored me with what it was doing and how quickly we were able to deliver really valuable insights. So I joined the team. So now here we are, and Kanoa is a Ignition Gold technology provider, and we are providing this MES platform to manufacturers across the globe.
Awesome. And I can tell you, Sam, I'm excited about this webinar because, like I said, I've been doing this for 46 years from the SCADA side. And we always hear about, oh, Arlen, we're doing MES or we're doing MES over here. And really, from my perspective, it's always been kind of a black box. Oh, it's this MES thing. And I'm really excited for us to kind of really dive into it and go through the product that you've got and really kind of help clarify, even to me, what the heck MES really is.
I'll do my
So a
best.
little bit, yeah, great. So a little bit about CirrusLink to get started with. CirrusLink was founded in 2012, and we really wanted to provide MQTT-centric software for industrial automation. It was interesting in that when Andy and I invented MQTT, it was for Phillips 66 for their midstream pipeline. So it was a mission critical OT application. But over the years, it kind of migrated to where IT kind of took off with MQTT, and we really were left like, well, wait a minute, this was invented for OT. So we were able to get into that market, and we were very fortunate in that we're the only strategic partner with inductive automation. So that means really what we do 5 days a week, 8 hours a day, is we develop MQTT technology as modules that run on the Ignition platform. Now, we do have some standalone products. One of those is the Chariot Spark Plug Aware MQTT server, and the other is our line of IoT bridges that we can use to connect Ignition data that's being published in MQTT Spark Plug into various data platforms like the Snowflake Data Cloud platform. Now, we are going to be leveraging MQTT in this demo, and I thought we would just kind of go over kind of the high points of what makes MQTT unique in this market. So first of all, you have to realize is that MQTT was designed as a stateful publish and subscribe infrastructure. And because it has state, i.e. we can connect, publish a value, then we don't have to publish it again until it changes. That gives us the ability to do everything report by exception. And when we do that, typically over the last 26 years we've been doing this, as compared to a typical pull response system, we're seeing 80 to 95% bandwidth reduction in the sheer amount of data. Now, 26 years ago for Phillips 66, that was 80 to 95% savings in their VSAT costs. But today, 2025, maybe we look at that as the opportunity to bring 80 to 95% more stranded data up in the same amount of bandwidth that you're using today with poll response. Now, again, since MQTT is a pub sub infrastructure, one of the really cool things that it does is it decouples data producers from data consumers. So in the automation world, for the last 46 years that I've been doing this, we typically hard code our PLCs, our sensors, our automation system to a system that's doing the protocol. So we're really hard coding these systems one after the other after the other. And it works great until you want to come in and you want to pick up some data that's stranded. And now you find that that system is very hard to modify. It's very hard to make it future-proofed with easy migrations. But the decoupling of MQTT lets us go to the edge, publish all the data that we might be interested in, and then have different data consumers subscribe to that data. The other huge advantage of MQTT is its zero trust security. MQTT makes an outbound TCP/IP connection from the edge to the central MQTT server. So that means if you're talking to your IT department about security and they go do at your factory, at your remote facility, there are no ports open from a security standpoint. The other thing is that MQTT was designed to sit right on top of TCP/IP. A lot of people look at the spec and they go, Arlen, we can't use MQTT. You guys didn't put security in it. No, we didn't do that on purpose because we're leveraging the security of TCP/IP. Today, that's TLS technology. Tomorrow, that could be something different, but you will always be able to take advantage of the latest security. So MQTT has been around, it's tried and tested for over the last 26 years, and it really gives us a common base technology that can be leveraged both by your OT infrastructure and your IT infrastructure. Now, again, one of the great things about MQTT is number one, it's super simple. It's secure. We talked about that, and you can publish any data that you want. Since it's a binary payload, you can publish anything you want on any topic. But as we got into this, we started doing more and more system implementations. The problem became you can publish anything you want on any topic. There was no standard on what topic was being used or what payload structure was being used. So therefore, there was no interoperability. So about 7 years ago, Cirrus started, for our own sanity, if you will, to put together a spec leveraging our years of experience and take all of our lessons learned, best practices, and create a spec, and we called it Sparkplug. And Sparkplug literally is a specification that defines how best to use MQTT in a mission-critical real-time environment. Realizing the spec doesn't change any of the underlying MQTT technology in any way, it just gives you 4 very simple offers in the specification. So number one, we defined an OT-centric topic namespace. And the result of that is plug and play auto discovery. So that's the most important part of the Sparkplug spec, is the fact that we know what to subscribe to, we know the structure of the topic, and that defines the payload for us. Now, the result of that is plug and play auto discovery on information that's being published. Now, the second thing the Sparkplug does is it lets us basically publish a template definition from the edge of the network. So if you think about what we can do with platforms like Ignition, we can define data models. You may know them as UDTs, user-defined types. And those are very powerful. But what we're able to do with Sparkplug now is basically take that model definition and publish it using Sparkplug so that your entire auto discovery includes the fact that you can discover data models from the edge. And that really goes into this whole unified namespace, single source of truth aspect that a lot of manufacturers are looking at today. Now, you've got your UNS through your topic namespace creation, you've got your hierarchy, you've got your data models. Now we're getting down to, now we go all the way to a process variable. Well, Sparkplug defines basically a binary encoding very efficiently of your process variables, your temperatures, your pressures, your flow rates, your tank levels. And when we get down to that measurement, immediately we know where it came from due to the UNS. We know its name, its value, its timestamp in milliseconds, its data type, engineering high, engineering low, damping, quality, and any other custom property you want to decorate that measurement with at the edge can be automatically discovered by anybody joining this MQTT infrastructure. And finally, as I said before, MQTT is stateful. And that means what we do is, as a client, when you connect, you tell the MQTT server, hey, here's my last will and testament. If I die, if my TCP/IP network goes away, if the cellular network goes away, if the VSAT goes away, if somebody cuts an Ethernet cable, then I want you to tell the world that I died. And that's basically this notion of a last will and testament. So all we did in Sparkplug is we defined that very well so that applications like Ignition, like other applications, would know what to subscribe to maintain the state of all of the devices in our MQTT infrastructure. So as you can see, Sparkplug basically helps us establish a single source of truth for our models, assets, and tags at the very origin, at the edge, for a complete unified namespace. So with that, I'm going to hand this over to Sam, and he's going to go through what the Kanoa platform is. So Sam, I'm going to make you presenter right now.
Great. Thank you, Arlen, for all of that. And a good handoff point too, right? Because what Arlen's showing here is how Cirrus Link and MQTT can deliver all of this data to the UNS or to your Ignition application, or to both, to your Ignition application through the UNS. But you need to use it, right? And Kanoa is one application that you can get that is hungry for data, like you are going to pump into this UNS system, and we will build this intelligence on top of all of that data to start having you better understand what you made, when you made it, how you made it, and really making sure that you are satisfying the manufacturing goals that you need to complete on a day-to-day basis. So at Kanoa, we make Kanoa MES. This is our off-the-shelf platform that plugs into Ignition, helps you drive continuous improvements, and gives you a fully functioning MES solution right out of the box, while also leveraging the power of Ignition to be infinitely extensible. So to dive into that a little bit more, so a lot of people here probably know Ignition already, right? Cirrus Link makes modules that plug into Ignition, as does Kanoa, where Cirrus Links are more around that MQTT communications. Kanoa is to deliver a MES. So in addition to the module that we deliver, we also are going to give you a database and an Ignition project. And between all of those together, you get this fully functional MES application with a strong structured database behind it. And that whole application is just built using out-of-the-box Ignition tools whenever possible. So if you know Ignition and you know Perspective, you know 75% of what you need to be extending Kanoa to make custom operator screens or specialized reports, all leveraging data from our platform. So really, what we are delivering for you is performance and execution management, right? We provide modules that let you record your OEE and downtime, manage your schedules, track your orders. We do quality and compliance, right? Being able to do inspections, process controls, SPC, tracking and enforcement of everything that you've made. And as we're tracking that, we also give you traceability. So this power to be able to take a finished good and see everything that went into making it, or take a raw material and see anything that ever used that, and do that full forwards, backwards traceability alongside that. We'll get into more specifics on all of that in just a little bit. But first, I do want to address Arlen's question, right? So I get this question a lot around, like, what is an MES? And it is something that I feel like is changing and is different for different industries and different applications. But two tenets I find to always be true. One MES serves as the communicator between your factories and your business systems. Very typically, an ERP is where you are starting with this, right? So an ERP is in charge of receiving in orders to your business and making sure those orders are fulfilled, but you need your manufacturing plants to actually do that fulfillment. So the communication between what is driving your business and your orders and what you need to make and your factory and what it actually is making. And an MES is typically one of the systems that is very uniquely good at talking to both the business platforms and your factories to merge all of that data together. And while it's sitting there in the middle of those systems, it is able to then supervise and organize your factories very well, right? So we can plan and plan all of that production we need to do, track its execution and what actually happens, and ideally be closing the loop to your ERP with this. So very commonly, your ERP will get a large number of orders, might assign those to a plant. You are then running that order at the plant, tracking your inputs and your outputs and your scrap and your downtimes and things like that. And then when you finish the order, we wrap up all that data, send it back to the ERP and say, this is ready to ship. Tell the customer their order is fulfilled. We do that across a number of different solutions. So just like Ignition is modular and you can buy different modules for the platform, we have a number of different modules in Kanoa, so you can buy the features that you need a la carte. Everyone gets Kanoa Core. This is kind of the free foundation that comes with any other Kanoa module, includes things like your security and user management, your navigation, our multi-language support and translations, things like that. Kanoa Ops is where we're going to spend most of our time today. So Kanoa Ops is our operations management platform. It is where most of our customers get started with Kanoa MES. This is where you are defining all of your assets, all of your materials, all of your work orders, scheduling that work, tracking production, kind of that closed loop I just described with the ERP platform. That's all covered here in Ops. The material traceability piece of it is our Kanoa Trace solution. So this is a lot traceability and genealogy system, being able to track each of those different production events by a material lot as it goes through your factory. And due to a recent update that we just did, we added routing and process definitions to this. So we're updating our solutions all the time with free features, bug fixes, things like that. Kanoa Trace just got a big update to not just track what actually happened at the site, but to define these routes and plans of what is supposed to happen and then track that against the reality too. So really cool extension and a good example of how we're improving this all the time. And then we also have Kanoa Quality. So this is a platform for designing electronic forms, managing their dispatching and scheduling, getting data either through those forms or through automatic tags through something like a Cirrus Link MQTT provider or through other factory data. And then we give you tools for SPC and other data analysis on top of that. So those are all the different applications that you can be buying from Kanoa that go into your Ignition platform to add these capabilities to your system. Before I jump into the demo and show you more about how we do that and how we can take advantage of Cirrus Link and MQTT to do some really cool extra stuff with this MES platform, let's talk about again, like kind of how this all fits together. And I've brought from Ignition's website here, their IIoT architecture and their enterprise architecture to kind of give a sense of how this could work, right? So Kanoa is licensed by the Ignition Gateway. So wherever you kind of need Kanoa in your architecture, which can change depending on your application, you could run it, say, on a centralized gateway up here that then looks at different site gateways over here, and maybe you don't need Kanoa at these sites. Either way, I'm getting into the weeds a little bit. The point being that MQTT is responsible for getting the data up to these Ignition servers, which could also be running your Kanoa MES platform connected to your database where we're storing all of your data long-term. The nice thing about using MQTT for this, a couple of things, all those advantages that Arlen just mentioned, but the couple that we're really going to be highlighting today are the store and forward capabilities, where if these connections between your site and your server breaks down, how we can maintain data integrity and make sure that we're taking advantage of MQTT at the site to get the backflush of data that we need. And the other thing that we're going to be showing is more around this enterprise architecture, right? One of the things that we really try to solve for at Kanoa is how we scale up these MES implementations. Doing OEE or scheduling for one line or for one area or even for one site might be kind of simple, but to scale that across your entire organization in a standardized way, especially since those might not be standard processes, becomes really complex. So how do we easily and quickly add more sites, more deployments, more assets to this MES without it becoming overly cumbersome to actually expand the system? So we're going to show some cool tricks around that as well. And then one final thing I might note before I get into the demo, we won't show this as much today, but maybe for the next webinar, the other opportunity is to really wrap in these other line of business applications you see here into a wider UNS, right? So if you're not familiar with the term UNS, Unified Namespace, right? The idea is that this is a single system, a single source of truth following a specific asset hierarchy for all of your manufacturing and business data, right? So we're not really worried about point-to-point communications between all these various systems anymore. Everything goes to the UNS to get and send its standard data. So the idea of getting our device data from the sites and our line of business data and our MES data all communicating to a centralized UNS, really powerful. And we've seen a lot of customers using that to really simplify their overall data architecture. Arlen, with that, maybe I'll hand it over to you to talk a little bit more about the topology for the demo that we're going to be showing next today.
All right. Well, I'll go through what we set up, and then Sam, you can go through what you've got set up for the demo.
Yeah.
But so what we did is that this demo is running on real Ignition hardware, real Ignition gateways, and we are using the OPC UA simulator that comes with Ignition. So real OPC UA data. And over on the left, as Sam said, I kind of put this notion of the unified namespace, the notion that we're going to organize our folder hierarchy from enterprise to site, area, line, and cell. And again, this is kind of the standard set, if you will, following ISA 95, but it really is just a suggestion. I mean, the UNS doesn't hard specify anything particular. It's what works for your business, right? So what you can see here is we've got a plant in Philadelphia, and Kanoa just went on a splurge and they bought a plant in Philadelphia. With a few lines, they bought a plant in Chicago, and they've got a new plant they've got coming online in Vancouver. And each one of those, you can see the folder structure within Ignition, the way that you organize your tags within Ignition kind of follow this notion of the unified namespace. Now, in addition to that, each of the machines that are in these factories are using UDTs to help define a model, if you will, for each of the machines. So for the Anvil casting machine, it's got all of the data, all of the tags. And remember, you can put other tags, you can put asset information in your properties on your UDTs and Ignition. So each of those become a self-describing way for you to identify all of your machines. Now, when Kanoa originally bought this Philadelphia plant, well, it was just kind of standalone sitting there. But all of a sudden they said, hey, we would like to get some MES capabilities. So all of a sudden, we started connecting these factories using MQTT transmission. With transmission, when you enable it, it goes to the tag providers that you've got with your folder structure and your UDT definitions, and it publishes that using the Sparkplug specification. Well, over here on the right, that's where we have an Ignition gateway running Kanoa MES. And without writing a single line of code, without doing anything, automatically MQTT engines knew what to subscribe to, was able to take that data and automatically build it out into the tag structure within Ignition. So what Ignition sees On the right side, running Kanoa MES is the single source of truth in real time of the Philadelphia, Chicago, and Vancouver factories. So, Sam, I'll let you go through what you'll be running on that Ignition gateway.
Yeah, perfect. So at this handoff point, we have our Ignition gateway. Actually, here, I'll show it. I'm going to bring up in one of my scripts here. So we have our MQTT engine, right, where we have our different edge nodes. This is the connection that we have out to those devices that Arlen just showed. And then what we're going to do is, now that we have all of this data and it's in Ignition, and we know that they've set up these nice UDTs for us too, right? So if I know that we're getting these into a specific structure and I have a certain expectation of the type of data that I am going to be able to get from these devices, it becomes very easy for me to write some routines on my side for us to quickly instantiate and connect to a lot of the source data that I'm getting from our MQTT engine. So this is where the Kanoa piece of this takes over, and our main demo kind of begins here. So this is what we currently have configured in Kanoa MES. Everything I'm going to show right now is kind of the out-of-the-box stuff that you can do just by clicking through and configuring the system without having to write any code. But there is a point in this demo where I'm going to say that now we're switching, and now this is some custom stuff that we did, but all custom stuff that is accessible to anybody that runs the software. So what are we seeing here? So I'm logged into Kanoa as my user, and one of the things that Arlen had mentioned was how we're following an ISA 95 style hierarchy. So you can see I have Kanoa Inc. here. I think we're a subcontractor maybe to Looney Tunes Acme Inc. as we make anvils and dynamite throughout these two plants in Philadelphia and Vancouver today, and we're going to add Chicago a little bit later. So you can see I have my enterprise, I have my two sites that each have their areas, where in this case for anvils, for example, I have two anvil casting areas with 9 stations in the first and 7 in the second, and then a shared packaging and crating station for all of those. And my dynamite factories are set up in a similar way. And then for each of these assets, I can kind of get some at a glance information for them. Let's make it a little bigger. So for example, in this anvil casting one, most of my assets are running according to their schedule. Some have been given a manual order to be running instead. If it is running a order, if it's not running an order, actually, if we're in a non-production mode, we'll show that I'm in maintenance or I'm on break or something like that. But if we are running production, we'll show the current state of the machine. Am I running like station 3, or am I faulted and why, like station 5? We'll show the order we're working on and the product that we're working on. We get a checkbox if our OEE is on track, and we get a little warning sign if we are below our target. So how did we get here? What did we set up to get to all of this? Well, first, I'm going to go into our configuration. I'm going to look in Ops, Assets. And one thing I want to show real quick is, as I'm making out these hierarchies here, we have these different asset types that we define, right? And one of the things that Arlen had mentioned is how when you're making the UNS structure, you can follow ISA 95, but you don't have to. Kanoa follows that same idea. So we give you this ISA 95 style hierarchy out of the box, but if you do need to break that and have business units between your enterprise and your site, or different subcells or something like that, we can absolutely accommodate all of that as you need to. So if I'm manually configuring some of these lines, here's some of the steps that I'm doing to make that happen. I'm defining this hierarchy of Kanoa Inc. Philadelphia area station. I'm saying that this is a line. I'm giving it a group called anvil casting. We'll come back to that later. So remember that we're doing that now. I'll also go through and define all of the modes that are appropriate for this asset. These are the things that the MES thinks that the machine should be doing, and are things that we can schedule. You're scheduled for production for a certain number of hours, and then we're doing a maintenance break, and then we're going idle or something like that. And then we also have all of our states as well. So we define a bunch of different states in here. They can be running or planned or unplanned downtime. And I have a bunch of different types of states appropriate for anvil casting or packaging. So different units, like if I go to crate station 1, There's just different states and downtime codes that are associated to this device. So we've set all of that up. And I'll also mention that I took this offline state here and I made it purple because this is what we're going to show when we disconnect from the UNS, and we'll make it really apparent now when I've disconnected that data source from our system. So this is how I set up the assets, right? Make that ISA 95 style tree, define modes, define states. The other things that we do are configure all of our materials. So Acme makes anvils and dynamite and anvil and dynamite crates. And we define all of our production rates. So for every single item that can run on a given station, we set up the expected speeds at which we can produce that item. So station 5 can make anvils at a rate of 60 units per hour, but actually we schedule it as if it only ran 50 units an hour because you probably doesn't run at 100% capacity all the time. I'll show also, since we're in here, for things like our crate stations, we do some different math. We're using package counts on here. So what we're doing is saying that this can take in 4 anvils every hour, but it takes 4 units of input to make 1 crate. So we're packing 4 anvils in a crate, and we'll do all the math properly for you on the back end for that. So I have all my assets. I have all my materials. There's a couple of other things that we can set up. The first is all of our production orders, right? So I am just kind of manually or programmatically creating these different orders. They have a name, they have a due date, they have whether they are released or in progress or scheduled. And these are the things that we'll go ahead and schedule on each of our assets. And we do that through these operations and shift screens. So if I'm looking at, say, my operations schedule for Philadelphia Anvil Casting 2 Station 6, we can see that I'm in the middle of this work order right now. I did a changeover earlier and things like that, right? So I can construct these schedules, and I'm programmatically making these right now, but we do have a scheduling system within here. So I can take any of these orders, drag and drop these in as I need to. I'll say we'll make 50 units, which will take about an hour, and it will automatically schedule this for the appropriate amount of time that we configured earlier. Great. I'll also mention that we do configure all of our shifts as well. So we do have a 3-shift rotation pattern going on in the Philly site, and all of the stations underneath Philadelphia will follow this pattern, as opposed to Vancouver, which actually just has a 2-shift rotation pattern that it's following. So back to our system overview here. So now you've kind of seen how we go through, we make this hierarchy, we define all the things that we can run, we're starting to schedule our assets. This is great, but there's 2 kind of things that we need to address. One is the actual data that we're getting from the plant, right? Me configuring this is one part of it, but then we actually do need to connect it to a certain amount of data coming from those edge devices and actually use it for our application here. And then we'll get into more of the deep stuff around the fun things we can do with MQTT. So in Kanoa, when I went ahead and configured an asset, if I mark this as OEE enabled, we automatically create the space for you to hook in your data from whatever data source you have. So coming into our Ignition designer, so remember earlier I was looking at the MQTT engine. I'll jump into the Kanoa tag provider. I'll look at Kanoa Inc. I'll look at Philadelphia, Anvil Casting 1, Station 3, line. So this is the UDT that Kanoa is going to automatically deploy for you. This inputs folder is where we want you wiring up your data. And for the demo we're showing today, we are getting 3 pieces of key data from all of these edge nodes and devices that we're getting. We're getting its in-feed count, its out-feed count, and its state. That is kind of like the minimum required information that we need to be generating OEE. We need 2 of 3 counters and a state tag. It can get more complicated than that. You could have it so we're getting work orders or other information from the equipment as needed. But for this demo and for this minimal information, this is what we need. And we're getting a lot of information from that, right? So the other thing maybe we'll show before we get into it is that right now, as we're tracking all of this and we're managing all of these schedules, if I click into something like Station 2, where we've overproduced on this order a little bit here, I can see how this has been running today. And I could look into its run review to see, let's say for the week, let's see. Oh, I haven't done too much on this one actually, but we can see the 2 orders that we've done here. I was idle, I ran this order, I did a changeover, I've started this new one. I'm getting this count information from those tags that I just showed you, and any downtimes that we're collecting, I am also getting from those tags, giving me the proper signals to trigger the logic in Kanoa. So with all of this, this is, you can kind of do anytime, right? Any data that you can get into Ignition, we can consume and create MES structures like this. But there's 2 really cool things that we want to show taking advantage of MQTT. And the first is store and forward. So as we showed in that architecture, here, I'll bring it up again real quick. We have 2 Chariot servers here. We have one that's managing Philadelphia and Chicago, another one that's managing Vancouver. I'm going to shut this down so that we start to store. And as Arlen was talking about, right, that notifies everybody, hey, this connection's no longer working. You need to start storing some data for when that comes back. So this will start to store any data that we may have missed while this connection is out. We'll turn the connection back on. The data will flood back in. It's like nothing ever happened. So coming to Chariot, I'm going to stop the server. I'm going to say yes. Coming back to my MES, boom, purple all over the place, right? We said that we were going to do that. So if you're on break or idle, we're still kind of showing that. But for all of these that are supposed to be running, we are currently offline. It means we're not getting live data from the system. One thing that's kind of cool though is that Kanoa is still working, right? We're still generating these schedules. If one of these were to switch to a new order or go into a non-production mode, we would track that according to its schedule. And let's do it over here for station 1. I'm going to jump into this. I'm going to go into its run controller. I'm going to pick a different order. Let's pick, I don't know, I'm just going to pick one random down here on the line and start that run. Okay, so now anything from this moment on, if we're getting more counts and stuff from the actual site, those should be counted against this new order that I just put in, which has changed since when we were doing this earlier, right? The other thing, let's actually show that this downtime processing is working, right? So the way that states work in Kanoa, I'm opening a new tab just to kind of show you the nitty gritty of this. We're going to look at station 1. I'm going to look at its state list. And we do a state lookup system. So if I send, say, a 10 into my state tag on station 1, we're going to say it was in a mold clamping failure, and that is the downtime that we'll record. So I'm opening up the original, this is the edge device. This is the thing that is providing the data into Kanoa. I'm going to jump into Kanoa. I'm going to look at station 1, and I am just going to manually switch its state to 10 and leave it like that for a little bit. So again, as we're working through this, we've logged the event, we've logged the timestamp too. So every single time we're seeing a change on these state tags, on these count tags, now this edge device is storing a record of the event that happens, the timestamp of it, and the value. When we reconnect, Cirrus Link and the MQTT team, they're going to backflush up that data, but it is the responsibility of the application to receive and process that data properly. So this is where I kind of said, like, some of the customization comes in. I did write some extra code to make sure that we're consuming this in the way that I wanted to for the demo and putting the right data into the right spots. That's code that we can make available. We do have some of it in Kanoa already, but this is kind of exactly where you want to implement this could change a little bit. But when I turn this back on, we'll get this stream of in feeds and out feeds and states, and we'll pump that into the right place in the Kanoa system. Okay, I think I've stalled enough. Let's go ahead and turn this thing. Oh, did I put this back into a running mode? I did not. Let's put us back into running. So we'll see that happen. And I'm going to go ahead and turn this back on. So now that that connection's in there, you're going to see these start to switch into running mode again. There we go. Their state might flicker a little bit as we're going ahead and streaming in all of that data, but all the information is going ahead and coming in. I can come back into station 1 right here. We can look at our run review. we're still seeing that change that I made, and we're seeing our new counts come in, and they came in against the proper order here. So now if I open this up, we're going to have a single downtime, and there's that bold clamping failure. Yeah, 1.2 minutes felt about right for the amount of time I stalled there. So there we go. All that data just comes right back in. It's like nothing ever happened, which is really cool. There's a couple of ways that we could be going through and validating that as well. I can be looking at our production counts here for the day. Let's look at a different station. Let's look at 3. Maybe pick a different station, like 1 again. Oh man, that's funny. I don't know why it's doing that. Definitely worked earlier when I was prepping, but that's okay. So what I'll do instead, maybe I'll jump into the downtime report also. So I'll look at that for the day on station 1. It's just these 2 that I've done. Let's maybe go to a different station. Let's go to station 6. There's a nicer downtime report. So we're getting in the categories, the actual reasons, duration by shift, count up by day, or by hour in this case, data like that. So all of this just comes back in once we establish that connection, which is awesome. The other thing, actually, Arlen, is there anything else that you want to talk about regarding store and forward before I get into the auto discovery piece?
No, that's great.
Great.
So with transmission, we have 2 ways to take our store and forward data. One is that we basically short circuit it right to the historian, and you can do this on a per transmitter basis, or we can play everything that happened while you were gone. We can play it in order, and that's the mode that you're using with the transmission module for this demo.
Absolutely. And that was a design choice that we thought about, right? We really could do it either way. If you did have this going to the Ignition historian, we could totally have consumed that data and used it. But what we wanted to do is we just didn't want to add another dependency. This will work whether or not you have the Ignition historian module, which is kind of cool.
Right, right.
Yep.
And that's exactly, we implemented that feature. Really, it was requested by a customer several years ago. It was for MES. So it really is a MES feature of the transmission module.
Cool. Great. So the other thing that we want to show is around the idea of auto discovery, right? So one of the cool things that Cirrus Link and MQTT can do is you can just be adding nodes in and they kind of auto discover and just populate into this UNS with the click of a button. And that's great. But then to implement these into your Ignition system or your Kanoa MES system, it can take a while to configure it, right? I kind of walked through all the steps earlier. Simple to do one time. If you're doing that for 330, 300 assets, that can become pretty cumbersome, right? But one of the cool things about Kanoa is there's nothing that I can show you in this through clicking in the interface that you can't also access programmatically. So again, this is some custom work here, but work that I'm going to wrap up into a project somehow and try to share, I think, sometime in the new year for you all. We did some auto discovery to see when new assets are added into the system and to automatically add them and configure them in Kanoa MES. So I used our customizable navigation here to add a couple of Cirrus Link webinar things for auto discovery. I'll mention these steps can and have been programmed into a single button and don't even need to be buttons. They could be running automatically on a timer script, but for the sake of today's demo, I've broken up this auto discovery into 3 different pieces. The first is the discovery piece, right? Just searching for instances of data that we can consume and that we know how to consume and add it into Kanoa. So we're going to look for any asset inputs or asset simulator UDTs within that MQTT UNS. And then we're going to convert it to a Kanoa tag path, right? Does it look like one of these hierarchies that we have here and try to see if it exists or not. So if I run discovery, okay, we found 33 different asset input UDTs. As we check those against our asset paths, we find 3 new assets, our Chicago Anvil casting stations, 1, 2, and 3. Yes, confirmed. I only have Philadelphia and Vancouver configured here. We have not added in Chicago yet. So the next thing I'm going to do is prepare that update. So we're doing a little bit of a background work here, right? Because remember when I mentioned that we were creating and designating asset groups for each of these. So I'm doing a little bit of a trick here, again, like a design decision. Since Anvil casting stations have their own set of states, and Anvil packagers have their sets of states, and these dynamite lines make completely different products and have their own sets of states, I don't want to have to define this every single time we do it. So what we're going to do is we've programmed this to try to figure out the asset group that a asset could be based on its path. And if it decides it is a dynamite fabrication station, it will look for other dynamite fabrication stations and copy one of those, therefore bringing across all of its states and materials and things like that. So essentially, we're using these that we've already defined as a template to then make our new assets. So we're going to go ahead and do that. We're also going to establish the path that we're going to connect to the data from, and we're going to figure out if we are going to copy something, we're going to figure out what that's going to be. The one other step that we did here is we figured out the non-UDT related assets that we're going to need. Yes, I saw data and I'm ready to connect to Anvil stations 1, 2, and 3, but I also need to make the Chicago plant and the Anvil casting area that's going to hold all of those. Okay, so now we have all of our information. We have the paths that we're going to make. We have some sources that we're going to copy. Let's do it. So I'm going to create the assets. The site and the area, those are pretty quick. They're just made quickly and automatically first. Then we start getting into the actual copying of some of this stuff. So we're duplicating station 2 here. That takes a little bit longer because we are doing all of the materials and all of the states and all of the modes and things like that. There's just more data to these. But once we're done with that, then the other things that we do are we move it to the right place in the hierarchy. We make sure it has the proper name. We connect it to that MQTT data and we set it to idle just so that it has an initial state. We've made 2, we've made 1, we're working on 3. And if I come back here into Kanoa MES and I refresh this asset tree, here's Chicago, here's Anvil casting, 1, 2, 3, all right there. Look at my home page. Here they are down here at the bottom, and they are ready to use. I can open up station 1. I can go into its run controller. I can start any of the orders that are currently in my system. Start that. Similarly, I could jump over to station 2. I can go into its schedule. I'll wait a minute for the orders to come in. I said I'll wait. There we go. And I can drag and drop one of these into, and we'll start to produce this guy. I have scheduled during shifts on. Give me just a minute. I know what I need to do to fix that. All right, partial 190. Great. Oh, still need to fix that. Okay, I should be able to schedule it. But here we are. We're running station 1 right now. We haven't seen any data come in yet, but we will. Up there we go. We've completed our first unit. Congratulations, everybody. We've done it. So one other kind of quick thing that I'll show, just to kind of go over that again quickly and to kind of show that we're not cheating too badly, right? I'm going to come back into our swarm over here. I'm going to collapse this again. Anvil casting 2 right now has 7 stations where 1 has 9. Maybe we need to expand casting 2 again. I'm going to copy station 7 and I'm just going to make 2 copies of that again. So again, this is all simulated data kind of populating up to us, but now all of a sudden I've commissioned 2 new stations into here. To send those back out and get them to the UNS, I'm just going to refresh our data from here just to resend that out to the world. And now, looking on our Kanoa side of things, right, if I'm looking in our MQTT engine into our edge nodes, to pick up that change, do I need to delete this actually? No, I don't. They're right there, station 8 and 9. And then what we're going to do is come back and we're just going to run that auto discovery again. I'll reset these, run discovery, found those, prepare the update. They're ready to go, create the assets. It's going to go ahead and duplicate those and put them right in. So what we're doing there is we are then creating these Kanoa Inc. sites, setting up their line UDTs. Oh, I don't know why I can't click that. And then we're pointing these three input tags to the proper point in the UNS based on this MQTT path right here. Oh, instead of adding a bunch of stuff automatically to the asset hierarchy. That's why this keeps bumping up and down. And again, coming back here, those new sites are now, it's got to switch to a different page. Now we have new stations 8 and 9 as well. Great. So with that, right, we've kind of gone through and shown some of those values of MQTT. We can do that auto discovery. We can pull in new data and add assets into this hierarchy automatically. And we're showing off that store and forward again, that I can just stop this server and we'll start buffering data as all of these things go offline, and they'll come back when they are ready. So Arlen, anything else that you want to add to that, or do we want to open things up for questions?
No, that was an awesome demo. Thank you very much. And that really helps in, for at least for me, in seeing how we went from basically a SCADA system, if you will, to an MES system, and how you're able to take advantage of that very, very quickly. And really, it was kind of seamless in the way that you're able to integrate in with an Ignition system. So really, anybody listening, I mean, if you've got Ignition, you're pretty much ready to go to take advantage of that. So that would be great. So with that, I think I'll open it up. And Kurt, do you have any questions?
There's a couple questions. Great job, Sam and Arlen. A couple questions came in. I guess one that's kind of common is maybe you both kind of reflect as, how do you get started? What's a good place to start? Both with, just how do you choose how to get going? And then maybe just how do you get started with CirrusLink or Kanoa on maybe doing a beta POC or something along that lines?
Well, I'll start really quick. Again, just like all of the other modules with Ignition, all of the CirrusLink modules, you can run them in trial mode for as long as you want to do your POC. So if you have Ignition, you can add an MQTT transmission module. You can point that at some of the tags that you may already have in your Ignition project. And then you can start publishing those to an MQTT broker. And, one of the nice things is we have the distributor module, which is an MQTT broker, and you can point engine at that. And literally within an Ignition project, you could do both. You could be transmitting data to a broker. You could be subscribing to that and see those tags show up in MQTT engine. Now, once you have that, then you call Sam at Kanoa, and Sam?
Yeah, we follow the same philosophy. You can go to our website, kanoa.ai. There is a download Kanoa button right there. You can't get us through the Ignition marketplace like you can CirrusLink. You do got to go to our website to go and get that download. But yeah, you can download that. You can install Kanoa in your Ignition gateway. You set up your tag provider. You point us to your Microsoft SQL database where we'll be storing all of your data. And when you run that installer, we will automatically create that database for you, set up our tag provider, and install all of the projects that I showed today, which includes your configuration and the user screens and application and the reports that we were running through. We've also got a YouTube tutorial series that you can use to walk you through everything from installing the module through setting up a simulated system like I show you today.
That sounds great. That sounds pretty easy. And I think if anything, like I believe Kanoa does as well, that we provide free support. So if you hit support at cirruslink.com, we're here to help you get going as well on that. Here's another question that kind of came up towards you, Sam. It says, you've shown store and forward for the OEE data, like counts and downtimes. How about quality SPC data or trace data? How does that come in?
Yeah, for sure. So it can all depend on the data source and the conditioning that kind of you have from that edge device. But this is just one example of how we did the data consumption from that store and forward pipeline. I happen to be using it for counts and states and things like that. But yes, if it was a number of different lot transactions or material movements, or if it was a stream of 100 SPC points where all of those timestamps were really important, yes, we can consume any of that, put it into the database in the right place, and again, make it look like nothing ever happened. Good question.
All right. Well, we really appreciate everybody joining this webinar. Just we'll be answering some of the questions that we get to currently on the call, but we will follow up with an email that has a link of the recording of the webinar and answer any questions that are outdated. Again, we appreciate everybody coming and look forward to working with everybody in the future. Any last words, Sam, Arlen?
I see a question or two in the thread. If we didn't get to your questions today, feel free to reach out to me directly. You can go to our website if you contact us through there. We're happy to go and help.
All right. Well, hey, Sam, again, I told you at the very beginning, I wanted to learn more about MES. You did an awesome demo. For anybody that wants, again, for questions, that you can hit us at sales@cirrus-link.com, and really appreciate everybody attending today's webinar. Thank you.
Yeah, thanks everybody. Appreciate the opportunity to work with you guys.